Hello. In this video, I'm going to show you how to use solubility graphs to determine the saturation states for solutions. So this lesson depends on two previous concepts, solubility graphs and saturation. So I'll review them really quickly. First, you should know how to read solubility graphs. For example, if I wanted to figure out the solubility of potassium iodide at 45 degrees Celsius, I would look at 45 degrees on the temperature axis. I would draw a line mentally to go up to the potassium iodide line, because that's what I care about. And I would look at the corresponding amount on the mass axis on the left. So the solubility of potassium iodide at 45 degrees Celsius is around 205 grams per 100 milliliters. Okay, so second, you need to remember the words unsaturated, saturated, and supersaturated. These are saturation states for solutions. So the solubility, that thing you read off the graph, that tells you the maximum amount that you can dissolve in a solvent. But if a solution has less than the maximum, we call it unsaturated, so it doesn't have a lot of stuff dissolved in it. If a solution contains exactly the maximum amount, it's called saturated, and if it contains more than the maximum, because you did some chemistry magic, it's called supersaturated. So you need to remember these four things for this lesson to make sense. Okay, so now new stuff. I'm going to take this solubility graph and temporarily focus on only one chemical to make this easier for you. Specifically potassium nitrate. That's what I'm going to look at. This blue line tells you the solubility of potassium nitrate at any particular temperature, the maximum amount that you can dissolve in water. So for example, at 30 degrees, using this graph, you can figure out that you can dissolve a maximum of 45 grams, about. And I'm going to simplify this by focusing only on the part of the line at 30 degrees. So if you only had 10 grams dissolved, you would be at 30 degrees and then 10 grams, and it would be at this red point. You would have less than the maximum. So the blue line is the maximum, but you have that red dot, only 10 grams. Any solution under this line with less than 45 grams in it would have less than the maximum. So that means that any solution under this blue line would be unsaturated because it's not at the maximum yet. It can still dissolve some more. And if you have more than 45 grams dissolved at this temperature, like for example if you had 70 grams dissolved, you'd be up here. You'd be at 30 degrees and 70 grams dissolved at this red dot. And you can see that this is more than the normal maximum. It's above that blue line. And so if you're above the blue line, you're going to be supersaturated because you have more than the normal maximum. And if you were exactly on the blue line, right here, so if, like at 30 degrees, you had exactly 45 grams, the solution would contain exactly the maximum amount. And it would be saturated. So with this potassium nitrate graph, at 30 degrees, everything on that red line under the saturation point is going to be unsaturated. Anything on that green line above the saturation point is going to be supersaturated. So these are the three possible states something can be in. You can figure it out graphically based on a solution's position on this two-dimensional grid. But it's not true for just this temperature. It's not only true for 30 degrees. For any temperature at all. If you are above that saturation line, you have more than the maximum amount dissolved, and you are supersaturated. And if you have less than that amount, you're unsaturated because you're not at the maximum yet. And if you're exactly on this line, you're saturated. So knowing this graphically, it lets us easily answer questions about whether a solution is saturated, unsaturated, or supersaturated if we have some numbers. So for example, this is the kind of question you can get. If you have 100 milliliters of water at 90 degrees and it has 130 grams of potassium nitrate, is it saturated, unsaturated, or supersaturated? Well, first let's look at the numbers. These are all going to be important. It says 100 milliliters of water, and notice that's the same unit that we have on the axis over there on the left. Technically it says grams per 100 centimeters cubed, but 1 centimeter cubed is the same as a milliliter. So this number just lets us know that the graph is the right graph. It's using the same units, 100 milliliters and 100 milliliters. 90 degrees, that lets us know that we are at 90 degrees on the temperature axis, and 130 grams of potassium nitrate, that's where we are on the mass axis, on the left over there. So at 90 degrees and 130 grams, we are right here. This point represents our solution. And it's below the blue line. It's under the solubility curve. And that means that this is unsaturated. So if you have 100 milliliters of water at 90 degrees with 130 grams of potassium nitrate, it's unsaturated because that point is below the curve. Two more real quick examples. And I'm going to use a more crowded solubility graph this time because this is the kind of stuff that you're normally going to be using. Not with one nice curve with a lot of unnecessary distractions. So if you have 100 milliliters of a solution containing water and sodium chloride, this is different. The solution is at a temperature of 30 degrees and it's got 50 grams of sodium chloride dissolved in it. Is it saturated, unsaturated, or supersaturated? To figure it out, well, the 100 milliliters, that matches our axis, so we're using the same graph. Sodium chloride is what I'm caring about, so this is the line that I'm going to use. The other two lines I'm going to ignore. It's at 30 degrees Celsius, so I'm at 30 degrees on the temperature axis. It has 50 grams of sodium chloride, so that's where I am on the mass axis. Those 2 points, if I take 30 degrees and 50 grams, that puts me here. And so, because this point is above the line for sodium chloride, which is the chemical I care about, this solution is supersaturated. So the answer to this question, 100 milliliters of water at 30 degrees with 50 grams of sodium chloride, it's going to be supersaturated because this point on the graph is above the solubility curve for the chemical we care about. Last one. So if you have 100 milliliters of water at 75 degrees Celsius with 150 grams of potassium nitrate, is it saturated, unsaturated, or supersaturated? Well, just like before, the units match up, 100 milliliters, so we use this graph. We're at 75 degrees and 150 grams, so you figure out that point, and that point is exactly on the line. So if it's exactly on the line, it has exactly the maximum amount, and we call it saturated. So to summarize, we learned 4 things today. First, every possible solution, every possible temperature and amount dissolved is somewhere on this 2-dimensional graph. Not necessarily on the line though, just somewhere on the graph. If that point is below the solubility curve, then we call this solution unsaturated because it's not full yet. If the point is above the solubility curve, then the solution is supersaturated because it has more than the maximum. That means you did some weird chemistry magic. And if that point is exactly on the solubility curve, like it's right on the line, then the solution is saturated and it has the maximum normal amount. So if you learn these 4 things, then you got the point of this lesson. I hope this was helpful.